percentage by mass or percentage by volume. But before that, let's remember what is the concept of solution with a little experiment. I have some water here in this volumetric flask. If I pour it in this glass, do you have a solution here? The answer is I don't, because here I have only the solvent and I should have had solvent plus solute. So in the first glass I do not have a solution. So I have here some nuts, which could be my solute. So let's pour some water inside. Did I get a solution? No, because it's not homogeneous and nuts are also not soluble in water. Remember, solute means something which is dissolved in a solvent. Therefore, also in this second glass, we do not have a solution. Then, let's see to prepare a solution. I took here some sodium chloride, which is the kitchen salt, as everyone knows, or almost all of them. Let's pour it inside, then also some water, and finally I will stir it. Now it's everything dissolved and we finally get a solution because everything is homogeneous. There is no difference anymore between this and this. Great, I hope everything was clear. Bye. Let's start with the first problem, which is an application, so it's very simple. Let's start with the data. We have 15 grams of potassium carbonate. Let's write it. And this potassium carbonate was dissolved in 500 grams of water, so we have also 500 grams of water. Now the question is, what is the percentage by mass of all the components of this solution? Indeed, we need to know the percentage by mass of water, so H2O, and the percentage by mass of K2CO3, of course. So how we can manage this problem? We always need to remember the definition of percentage by mass. So we're gonna write it here. Percentage by mass equals mass of solute divided by mass of solution times 100. Well, this is our definition. Let's highlight it to recall it better. I will use the red marker. Yeah. We just need to put numbers into this equation because I told you that this is all an application problem, so it's very simple. Let's calculate first the percentage by mass of K2CO3. We know that we have 15 grams of K2CO3, so let's write it. This is divided by the mass of solution. Now we always need to recall that the mass of solution is given by mass of solute plus mass of solvent. I will write it here. Maybe it's not very visible, but I wrote it mass of solvent. So we need to write 15 grams divided by 500 grams of water, which is the mass of solvent, plus 15 grams of solute times 100. If you do your maths well, you will know that the solution is 2.9%. So now let's write the percentage of water. We know that we have 500 grams of water, so we need to write 500 now on the top of this equation, because now we consider the water as solute, but actually the water is the solvent. However, now I'm doing the percentage by mass of water, so I need to take the water up. So it is again divided by 550 grams times 100 is equal to 97.1%. Of course, since the water is more, the mass percentage of water is greater than the mass percentage of potassium carbonate. Great. That was the first problem, and as you can see, it was very simple. Only you need to put number into the equation on the top. Of course, you need to put this number properly. Let's move to the second problem. The second problem is very useful because it may serve to prepare a real solution in the lab. It may be that we have to perform those calculations. So let's see. Let's start with the data. I can write it. And what does the problem want? I want to prepare a solution made by 1000 grams of total solution. So it's 1000 grams of solution, which is 13% by mass of KCl, which is potassium chloride. Of course, the question is implicit here. We are asked to prepare this solution, so the question is implicit. However, the question will be how much water I need to put in order to prepare this solution. So how much water? In terms of grams, of course. And how many grams of KCl I need to use in order to make this solution. So let's pretend we are in the lab. How we can prepare these solutions? We always need to remember the definition of percentage by mass. Let's write it again, as we have done in the first problem. Mass of solute is divided by mass of solution times 100. Let's frame it again with the red marker so we can recall it. Now we have our definition. Let's try to figure out how to prepare this solution in the lab. I could use different kinds of glassware, but probably the more appropriated ones is Hermeyer flask. It looks approximately like that. Sorry for the drawing. We need also a cap to close the flask in order to seal the solution. So we need to put 100 grams of solution, but solution is made by solvent plus solute. So I need to weigh a certain amount of KCl. We can use a glass watch, for example, or also filter paper to weigh this amount on the scale. I will write it, draw it here. And so this is KCl. Now be careful, KCl is not red, but is white powder, like the kitchen salt. It's similar. How much do we need to weight? We need to use this formula. Let's put the data we have inside. we have the percentage by mass, it's 13%. The mass of solute is our unknown amount. So I will write X divided by my solution, which is 1000 grams, times 100. This is an equation with only one variable, so it's easy to perform. X equals 13 times 1000 divided by 100. We can simplify this fraction, and now it equals 130 grams. I hope it's visible, but it's 130 grams here. But what does this mean? This means that we have 130 grams of solute, but my solute is KCl. So this means I need to weigh 130 grams of KCl, and the rest is water. But the rest of what? The rest is the mass of water, which is given by the mass of solution minus the mass of solute. So it equals 1000 minus 130 grams. We have just calculated. You can see that the result is 870 grams. So I'll put 130 grams of KCl into this flask. KCl is solid. Then I will put 870 grams of water. So I will have my homogeneous solution once KCl is dissolved. Here we do not have to deal with the volume, unlike other concentrations such as molarity, which we will see in the next videos. There you need to take into account the volume, so solution cannot be prepared like this one. But now let's move on to the third problem. Let's see now the third problem. This one is a little more complicated, but it deals again with the issue about how to prepare a solution. Let's write down the data. We have 500 grams of water, and they want to prepare a solution which is 6.5% by mass of NaOH, which is sodium hydroxide. What is the question? The question is, how many grams of sodium hydroxide I need to add to 500 grams of water in order to prepare this solution? Again, this can be a problem you have to solve in the lab. For instance, you are asked in the lab to prepare a solution with 500 grams of water, and the solution should be 6.5% by mass of sodium hydroxide. So how do you do that? You need to know how many grams of sodium hydroxide to use. The problem is giving us the grams of water, which is 500 grams. So let's write again the formula, even if it's annoying. It's useful to see what data we have and what we lack. So what do we have and what do we not have? We have 6.5%, which is the concentration. So let's write it. This is our concentration by mass. But we don't have the mass of solid, so let's write it as X, because it's unknown. Then we have to write the mass of solution. We always need to remember that the mass of solution is given by mass of solvent plus the mass of solute. So we recorded the mass of solution. So what to put over here? The mass of solvent is given, and it's 500 grams, we know it. So we write 500 grams plus the mass of solute. that is the mass of NaOH, but we don't know it, so we can write it like X, because it's the same variable we have on the top. Everything is times 100. So now we have to solve this equation, which is slightly more complicated, but it's anyway an equation with only one variable. Let's solve it. So 500 grams plus X in brackets times 6.5 equals 100x. We can erase G this time to prevent confusion. Let's use only numbers. 500 times 6.5 is 3,250 plus 6.50x minus 100x equals 0. The subtraction of 6.5x and 100x is 93.5x minus 3,250 equals 0. It means that I will have 93.5x equals 3,250 because I have multiplied everything by the minus sign. So all the numbers are now positive. This entails x equals 3,250 divided by 93.5, which is equals 34.7. Actually, if you round it up, it's 34.8. What does it mean? It means that to prepare this solution, I need 34.8 grams of NaOH, which I will dissolve in 500 grams of water. The procedure is the same we have seen in the previous problem. So this was the third problem, and now let's move on to the fourth one. The fourth problem will help us to understand the topic of dilution, namely how to go from a more concentrated solution to a less concentrated one. So let's see this problem and let's start writing the data. So what we have this time? We have 1 kilo of solution of nitric acid, which is 56.5% by mass. So it's solution and it's 56.5% by mass. Then we want to prepare another solution which is 20% by mass. So we have to go from one more concentrated solution to a less concentrated one. The question is, how much water I need to add to the solution of 56.5% in order to gain a solution of 20%. So let's write mass of water to add here, just to remember what we need. First, we have to understand what this problem requires. Let's draw a volumetric flask this time to figure out what we have to do. So this is our volumetric flask, which is has a longer neck. This flask has a line here to indicate the volume. I will draw it slightly better because it's not properly like that. So inside this flask there is the solution we made. The solution has a concentration of 56.5% by mass of nitric acid. So it's here. The problem requires the solvent. the solvent that I need to add to reach 20% concentration. Okay, so I need to add some solvent to reach 20% concentration inside this flask. So what I have to do is to make a dilution of this solution. So let's use our method to write the formula of percentage by mass. The mass of solute this time is HNO3, so let's write directly HNO3 and then the solution as water plus nitric acid times 100. So what happens here? It happens that I need to add water to dilute. So I need to add water in this flask. However, something is fixed here. And what is fixed? It's the mass of nitric acid that I have in the flask. This amount won't change. And I can also calculate it using the formula. So I will use 6.5% to calculate our X, which is the mass of nitric acid. And everything is divided by 1 kilo. Oh, sorry, here is not written very well. I need 1J. So here I will write 1000 grams because it's better to use grams in this case. So 1000 grams and not kilos times 100. It's equal to 6.5 times 1000 divided by 100. We can simplify these fractions to obtain 565 grams, which is our mass that is in this flask. So now I know the mass of nitric acid in my flask. This means I have all the data for the 20% solution. So let's write it. 20% solution equals the mass of nitric acid divided times 100 and divided by the mass of solution, which we don't know and we want to know, but it's the mass of final solution. So pay attention to this. This is the mass of final solution, the solution we want to reach after the dilution. So this is equal to 565 divided by 20 and times 100, and it equals to 2825 grams. I will erase this first part here just to have more space. So we got 2825, which is the total mass of solution. But the problem, so this is the total mass. But the problem was asking the mass of water to add to this solution in order to obtain the less diluted solution, which is 20%. Why the problem was asking that? It's not that the problem is mean, but it's because actually in the lab we need to know this number to make this solution. So it's very useful. Great. The calculation is simple now because the mass of water to add is given by the mass of previous solution, which is 1 kilo, minus the final solution. So let's write it. The mass of water to add is equal to 2825 minus 2825 minus 1000, which is 1825 grams. If you like to convert everything in kilos, it will be 1.82. We can just use this time only 2-digit because the problem was giving me at the beginning just 2-digit numbers. Great, that was the answer to our fourth problem, which was very important in order to understand the topic of dilution. And dilution is very routine task in the lab, so it's important to know it. How to go from more concentrated solution to a less concentrated one. Now let's move to the fifth problem. So I will erase everything here. Now it's time for the fifth problem. With this problem we will introduce the topic of density. This is likely the most difficult problems we have in this series. Then let's start soon. So the data are we have a solution of 38% ACl, and I know that the density of this solution is so density is 1.19 grams on milliliters. The question is to calculate the mass volume percentage. So we have to calculate the mass volume percentage. So this time is not the mass percentage, but it's the mass volume percentage, so it's different. So how to solve this problem? As usual, let's write the definition of mass volume percentage. It's the mass of solute divided by the mass it's the volume, not the mass, of volume of solution times 100, of course. In this case, I cannot simplify the units of measurements, so it's important to specify the units I will use. We will use grams and milliliters for this solution. Keep in mind the units this time. Let's write again the formula of the percentage by mass, because we have it again, so let's write it. So it's percentage by mass is mass of solute divided by mass of solution. If I write here J and J, see that I can simplify that here. So I can use also kilo. The important thing is to write kilos both up and down, so that can be simplified. Therefore, for the first formula, I need to be careful with units. For the second formula, I don't need it. Now, let's be back to our problem. So I have 38 mass percent of ACl solution, and I don't know, let's pretend someone in the lab or for some publication, they say to me, you know, I don't like this concentration. Convert everything in mass volume percentage. So how I can do to change the number? Apparently I have few data. I don't have the mass of solute. I don't have the mass of solution. So how I can do if I don't have the mass of solution to go to the volume of solution, for instance? So in this case, how I can work out? We can use the concept of 38% ACl in this way. So 38% equals how many grams of solute? Well, 38 grams in 100 grams times 100, of course. Because if I simplify, I will get 38 equals 38. So if the problem does give me those data, I can always express the formula in this way. Why? because we are dealing with solution and solutions are homogeneous. So I can use the concept of solution and say, okay, I have 38 mass per percent, so I can consider it as 38 grams of solute in 100 grams of solution times 100. So I have the data now that apparently were missing, and we can move on. So I hope this concept is clear, and now we have everything. The mass of solute is 38. So mass volume percentage is equal to 38 grams times 100. But now the volume of solution is missed. I know only that the mass solution is 100. So only one data is missed. So we are better off than before when we lack more information. Now let's erase here, because now we have to understand the density, the concept of density. When we have to deal with the density, density is always mass divided by volume. As units we have grams and milliliters, or the same can be cubic centimeters. So you can sometimes find grams and cubic centimeters, but it's the same. This is the density of solution. Be careful, this is the density of solution, not the density of pure ACl, which is a gas, by the way. So it's mass of solution divided by volume of solution, and it is equal to 1.19 grams on milliliters. So since I know now that the mass of solution is 100 grams, I can write it here. So it's 100 grams divided by volume of solution, and it's 1.19 grams on milliliters. This entails that the volume of solution is equal to 100 grams divided by 1.19, and it's equal to 84 milliliters. Maybe it's not visible, but we are going to write it here because it's the missed data. So we missed 84 milliliters here, and so this was the only data we lacked. So now we can calculate the percentage, the mass volume percentage. If you do your maths, you will see that this is equal to 45.2%. So this was the last data. This is the solution of the problem. The problem was apparently more tricky, but we needed to use the concept of density to solve it. I hope it was clear, and I'm going to write everything. I forgot to tell you that the previous problem, so problem number 5, can be solved also with a different strategy. If you find it, please write it down in the comment. I will tell you if it's correct. Now, let's move on to the 6th problem, which is similar to the 5th one, but it concerns how to go from mass volume concentration to percentage by mass. Let's write the data. We have a solution of nitric acid, which is 6.55 gram per liters. So unlike the previous problem, this time I have liters as unit and not milliliters. So pay attention to the units of measurement. So we have gram per liters. Please note that this time is also not a percentage, so we don't have to multiply it by 100. So pay attention also to this. As further data, I have density, which is 1.310. which is gram per milliliters. So what is the question for this sixth problem? Let's write it. It wants to know the mass percentage of our solution. So it's again a problem about conversion, going from one concentration to another. This kind of exercise can be useful in the lab if someone is asking you to go from one concentration to another one. So it's again a useful exercise. Or maybe in the lab you need to prepare a solution which is a mass percentage solution, but you have something already prepared which is grams per liter. So you need to do this conversion in order to understand. Now let's solve this problem. We have to write here nitric acid, I forgot it. So let's write the definition of gram per liter solution. So which is mass of HNO3, so nitric acid, divided by volume of solution. So we have again nitric acid and water, so this solution is made by these two components. Everything equals 6.55 gram per liters. Let's write also the units here, gram liters. Now let's write again the mass percentage definition, which is a mass of solute divided by mass of solution times 100. Let's frame it again, as we have done more and more times. We have in the data also density. So let's remind what is the density of something. Density is equals mass of solution, because this time it's giving us the density of solution, so the density of nitric acid plus water, the density of all the solution, divided by the volume of solution. So pay attention to the concept of density. Let's solve the problem. How to do? We don't have the mass of solute. Apparently we don't have it, and apparently we don't have also the mass of solution. But again, what we have? We have 6.55 gram per liter. So I can say that I have 6.55 grams of nitric acid in 1 liter, because I'm saying 655 is equal to 655 divided by 1. So it's like 655 equals 655. So it's of course right. So in the end, I know the mass of solute. Mass of solute is 655. So I can write it in the percentage by mass definition, divided by the mass of solution times 100. I don't have the mass of solution. So I know that the solution is 1 liter, and I can go from liters to mass, from volume to mass. How? Using the concept of density. So density is equal to the mass of solution that I don't know, so it's my unknown quantity, is my x, divided by 1 liter equals 1.310. So density is expressed with milliliters, so I cannot use liters here, and I have to put 1000 milliliters. So pay attention to units again. This entails that the mass of solution, which is my last unknown quantity to put in this equation, equals 1.310 times 1000 equals 1310 grams. So this is the mass of solution, and now it's very easy to calculate the percentage by mass, which is the answer to my problem. So it's 6.55 grams divided by 1310 times 100 and if you do your maths, it's 50%. So this was the answer to my sixth problem, which help us to use the concept of density to go from a concentration expressed in volume to a concentration which was expressed only by mass. Now let's move on to the seventh problem. In this problem, we will see that inside the concept of percentage by mass, there will be also the concept of mole. And as you may know, the concept of mole is everywhere in chemistry because it's the basic concept. Let's see now this problem. So let's write down the data. So we have a concentration of 96.4 of sulfuric acid, so it's very strong acidic solution. The density of this solution is 1.835 gram per cubic centimeter or milliliter. So what is the question of this problem? The problem wants to know the volume of this solution, which contains 1 mole of our acid. So let's write 1 mole of acid. Therefore, it's asking the volume of solution with 1 mole of acid. Probably we can write also with this symbol in maths, if I remember well. So let's start from what we know, and what we know is the formula of percentage by mass. So percentage by mass equals mass of solute, as we have written many times. Here I did a mistake, is sulfuric acid, not nitric acid, but it's not changing our problem. So divided by mass of solution times 100. I'm very bored to write this formula. I think I will also have a nightmare about that tonight. But let's go on. So to understand better, let's do a drawing of what we have. This is our volumetric flask, with probably also a cap on the top to avoid evaporation of the solvent, which would change the concentration. So inside this flask there is our solution, which is 96.5% of sulfuric acid. The problem is asking me to calculate the volume of 1 mole of sulfuric acid. So the volume in which is contained 1 mole of sulfuric acid. This is the question of our problem. Now pay attention to the fact that these calculations are possible only because we are dealing with solution, so with the concept of homogeneity of solution. If inside this flask there is a precipitate, for example, this calculation wouldn't be possible. So to solve this problem, we have to think that 1 mole of sulfuric acid has a weight. So I can put this mass inside the formula, and then also I can put inside this formula the percentage that I have to calculate the mass of solution, which is containing this mass of solute. Then using the density, I can convert this mass of solution in volume, and this is the question of my problem. So 96.4 equals mass of solute, so of sulfuric acid divided by mass of solution times 100. So I will use this formula as software in which I can put my data and have the answer of what I need. That's the point. So now I can calculate the mass of sulfuric acid using the concept of mole. So how we can calculate the mass of 1 mole of something? We can do that using the molar mass. So we know that the mass of something equals the mole times the molar mass. So now this means that the mass of sulfuric acid is 1 mole, because I have 1 mole to calculate, times the molar mass of sulfuric acid, which is something you can calculate using the periodic table, or just Google it and you will find it. So it's 98.08 grams per mole. So of course, this time, since we have just 1 mole, this means that the mass of nitric acid is equals to 98.08, so it equals the molar mass of sulfuric acid. So the mass of sulfuric acid is 98.08 gram per mole. Of course, this is intuitive, but I just explain it to be more clear. So now I can put this mass inside my formula here, and we can write it directly here. So it's 98.08 grams, and so now I can calculate the mass of solution. So the mass of solution equals, pay attention that this is the mass of solution with 1 mole of sulfuric acid. So we have all the time to contextualize this formula with what we are doing. So we have now the mass of solution with 1 mole of sulfuric acid inside. So pay attention to that. Equals 98.08 divided by 96.4. So I can times 100. I can leave here G equals, let's see, it's 101.7. So now, thanks to the concept of density, we can go on and calculate the last data. So density is again mass of solution divided by volume of solution. So the problem is giving us the density of solution, not the density of pure sulfuric acid. We didn't need the density of pure sulfuric acid. It wouldn't be useful. But we need the density of the solution. So pay attention also to this. And now I can calculate the volume of solution, which will be equals to the mass divided by density. So it's 101.7 divided by 1.835 grams per milliliter. Here is grams. So grams and grams, it's simplified, and we will have a milliliter. So it's 55.5 milliliter. So the answer to this problem is that the volume is 55.5 milliliter. So we have done also this problem, which apparently was slightly complicated. Similar problem could ask you to calculate the volume of 1 grams, for example, the sulfuric acid, but it's exactly the same we have already done. It's just that you have to put directly grams inside this formula, so it's even easier. Far we have dealt with the concept of percentage by mass, but now we will go through the concept of percentage by volume with this eighth problem. Percentage by volume can be helpful when you are treating in the lab, for example, mixture of solvents. So it can be also useful to know this concentration. Let's write down the data, and I will read now the problem. Some anti-freezing mixture are made by alcoholic solvents. Prepare 7 liters of solution, which is 35% by volume, this time, of methanol. Methanol is in water, and consider the volume additional. So the question is the volume of methanol which I need to prepare this solution. So as usual, we have to write the formula for the percentage by volume. It's similar to percentage by mass. What is changed is that we have this time to use volume instead of mass. So volume of solute is divided by volume of solution times 100. We can use both milliliter or liter as units. It's not important because it's a ratio. The important thing is to use milliliter up and milliliter down, or liters up and liters down. We cannot use liters here and milliliters here. It will be wrong. What is the volume of methanol we need? We have to put our data inside the formula, and then it will be easy to solve this problem. Let's write 35, which is the percentage of our solution, and then volume of solute, which is the volume of methanol, divided by volume of solution, which is 7 liter, times 100. So it's very simple equation, and we can easily calculate the volume of methanol, which is equals to 35 times 7 divided by 100. It's everything equals to 2.45 liters. Great, that was the answer to our problem. As you can see, this problem was very easy. It was just a practical problem. Let's move on. Finally, we reached the last problem. So let's write again the data. So we have the density as first data of pure ethanol, which is density of pure ethanol is C2H5OH equals 0.790 grams per milliliter. So we have the density of pure ethanol. So we have a solution of ethanol in water, which is made by 39.5 grams of ethanol. In water, the solution is total 400 milliliter solution. The problem is telling that you have to consider the volume additional. Why that? Because in chemistry, not all the time the volume are additional. Sometimes they can change. The total volume can change. So the question of our problem is, what is the volume of ethanol in water? So it's asking the volume of ethanol in water. It could ask also the volume of water in this solution. It's relative, everything relative. We have to think that everything is relative to what we are considering. But now it is asking the volume of ethanol. So let's write our formula. Volume of solute divided by volume of solution times 100, it's our definition. So as usual, let's see what we have and what we do not have. So the percentage by volume is our unknown quantity. Then the volume of ethanol. So the volume of solute is something now we don't know directly. but we know the volume of solution, which is 400 milliliters times 100. So that's the data we have. So now how to calculate this volume of ethanol? We have actually the grams of ethanol here, and then we have the density of pure ethanol. So please pay attention that this time we have the density of pure ethanol. So it's ethanol which is pure 99.9%. So let's write it to clarify it better. Density of ethanol we have equals the mass of pure ethanol divided by the volume of pure ethanol. So it's not the density of solution as we have seen in the previous problems, but it's the density of pure ethanol. And now we can use it to calculate the volume of ethanol using the mass of ethanol that we have in our data. So this entails that the volume of ethanol equals the mass of ethanol divided by the density of pure ethanol, which equals 39.5 divided by 0.79, and so this is the volume of ethanol we can put in our formula to calculate the percentage by volume, which is the answer to our problem. So let's put it here, 50.1, and equals, everything is equals to 12.5 milliliter. So that was the answer to our last problem. I hope everything is clear, and I'm happy because I have done for today. Bye.